Welcome back to my third episode of online lecture series on basic principles of group theory and spectroscopy. This lecture is tagged under the code L01-A2. In this lecture, my aim is to explain the various symmetry elements and symmetry operations present in a molecule with the help of molecular animation softwares, particularly using JMOL application. And then I will group them together in the form of what are called point groups. Alright, so let me now introduce in another couple of minutes the term symmetry operations and symmetry elements. A symmetry operation can be defined as any operation which moves a molecule into a new orientation equivalent to its original one. So this means that the effect of a symmetry operation is to take a body into an equivalent configuration which is not necessarily identical to original configuration. So it may be in some other configuration, but both original and new configurations are indistinguishable. Say for example, if I take a boron trifluoride molecule, we know that boron trifluoride is a planar molecule and each bond is separated by an angle of 120 degrees. Now if I label each fluorine atom as F1, F2 and F3 and start rotating the molecule in clockwise direction about an axis passing through the center of the boron atom and perpendicular to the molecular plane at an angle of 120 degree, then you can see that the first fluorine atom goes to the position of third fluorine atom, and third one goes to the position of second, and second goes to the position of the first fluorine atom. And since the axis is passing through the center of boron atom doesn't move at all. Now if we could label fluorine atom like this, we could observe clearly that the molecule had been moved. But since all fluorine atoms are indistinguishable, we cannot label these molecules, and the new configuration, that is the configuration after rotation, is entirely equivalent to the original configuration. Now we all see that the molecule had moved, but we cannot distinguish the configuration before and after the operation. Such a movement is a symmetry operation. Now you should keep in mind that I have used the word equivalent and not identical. This means that the effect of operation is not to take the molecule into an identical or original configuration, but to some other configuration which is equivalent to original configuration. Now here is another example. The molecule shown here is para-dibromobenzene, and we all know that this para-dibromobenzene is a planar molecule. Now consider an imaginary plane that bisects the molecule in the middle and is perpendicular to the molecular plane. Now if we reflect the molecule through this plane, the resulting orientation becomes indistinguishable with the original one. Now in this case, what we did is we reflected the molecule instead of rotation, and this reflection also leads to an indistinguishable configuration, and hence this operation can also be regarded as a symmetry operation. Now take one last example of a different symmetry operation. For that, consider an ethane derivative as an example, and name of this compound is dibromo-dichloroethane. Assume that this molecule is in staggered configuration. If we now invert each and every atom through an imaginary point, that means we have to translate each and every atom to its opposite diagonal through this imaginary point at an equal distance. After the operation, if you can see an equivalent atom on the other end, such an operation becomes a new symmetry operation, and this operation is called an inversion. And the point through which each atom is translated is called an inversion center. Now, from all these three examples, you might have seen that the symmetry operation is performed through different geometrical entities. Say, for example, in the first case, the operation was carried out through a line or an axis. And in the second case, the operation was done about a plane. Whereas in the last example, the operation was carried out about a point. These geometrical entities are called symmetry elements. So a symmetry element is defined as an imaginary geometrical entity such as a line, a plane or a point with respect to which a symmetry operation is carried out. So in this lecture, I hope you understand the difference between the terms symmetry element and symmetry operations. And to explain these two terms, you might have seen that 3D graphics model is extremely helpful to recognize and visualize these symmetry operations. In my next lecture, I will explain the various symmetry elements and symmetry operations that are present in various molecules by taking as many examples as possible, wherein I will be using graphics models and animations extensively throughout this module. Now in the end, you can get the updates on my video either by subscribing to my channel or by visiting my profile page. So see you in my next lecture.